Welcome to the Network Engineering Video Blog. I'm your host, Michael Crane. I had a user, a viewer with username of Tarandre ask if the Xena Compact supported TCP. And I replied back yes and said, you know, I can make a video showing how to set it up. Well, I may be wrong on that. You can add a TCP header, but does it support it? Let's find out. Well, according to the Xena documentation on their website, I'm going to read this off my screen. It says RFC 6349 based TCP throughput testing and stress loading testing is, of course, supported by Xena Networks Test Solutions. To generate test signals with stateful TCP traffic for throughput testing and for generation of very high number of concurrent TCP connections, the Xena Networks testers supporting layers 4 through 7, Xena Scale and Xena Appliance. Testing at lower layers like RFC 2544 testing is supported by the Xena Bay and Xena Compact test chassis equipped with relevant test modules. Okay, so what exactly are they talking about? There's a lot of numbers floating around there. RFC 6349, RFC 2544's layers. Let's take a look at that. So why the interest in TCP? Network engineers are only really interested in layers 1 through 3, right? You've got the Ethernet switch, which is a layer 2 device. You've got the router, which is a layer 3 device. TCP, that's for the IT folks, right? Or is it? What devices would a network engineer be interested in? Well, there are actually a few. One of them would be the TCP proxy, or a session border controller, or a NAT device, network address translator, or a PAT device, which is a port address translator. And that's just right off the top of my head. There's probably more SIP devices. Well, that could be kind of a border controller. So yeah, we are interested in TCP because we have to implement a lot of those devices in our networks for our customers. Okay, so the two RFCs mentioned in that Xena document was RFC 6349 and RFC 2544. And I'm going to read you the titles of them. 6349 is TCP throughput testing, and that's testing the nut, which the nut stands for network under test. I love the terminology though. Using RFC 6349 requires a TCP state machine. RFC 2544, let me read you that one. That's benchmark methodology for network interconnected devices. And you gotta love network engineers. So one of the comments in that RFC is to eliminate the smoke and mirrors from device manufacturers' testing results. So anyway, you should give that a read. It's written by network engineers. You'll love it. I'm sure it's loaded with all kinds of little remarks like that. So anyway, just briefly, so this right here is going to require more of a layer 4, let's say, and this guy right here is a layer 2-3. All right, and I know it. You guys, there's probably arguments on both of these, but anyway, just for our video today, we'll just leave it at that. Okay, so the Xena Compact is a layer 2 and layer 3 device. So really it can't really do 6349, but I want to read you an excerpt out of RFC 6349 that you should keep in mind. It says this methodology proposes TCP testing that should be performed in addition to traditional tests of the layer 2-3 type. Okay? It says, in fact, layer 2-3 tests are required, in all caps, to verify the integrity of the network before conducting TCP tests. It also goes on to say that annual packet layer test techniques where packet throughput, loss, and delay measurements are conducted, which is what I've been doing videos on on that lag testing for the past few months. Okay, one last thing to note about RFC 6349 that I wanted to read you is it says, important to note are some of the key characteristics and considerations for the TCP test instrument, which in this case would be the Xena Compact. It says the test host may be a standard computer or a dedicated communications test instrument. In both cases, it must, in all caps, be capable of emulating both a client and a server, which means that it's got to support the TCP state machine, okay? And the Xena Compact does not do that, all right? You'll need those other two devices that I mentioned earlier when I was reading from the Xena documentation. So, but is this still useful? And for some TCP testing, and I would say according to this RFC up here, this is a requirement before you even do this. Okay, so I've got the Xena Manager fired up, and I've got plenty of videos how to set all this up, so I'm not going to go through that again. I took one of my UDP streams on port 0 and deleted the UDP header out of it, and I'm going to go ahead and add a TCP header right here. And the first thing we get is this limited checksum support. This warning, it says limited checksum support. There's actually two limitations in here, and so if you read this, limited checksum support, the TCP checksum field is pre-computed based on a payload of all zeros. No Xena test payload. And it says, and does not track modifiers on the header. So, oh, okay, well maybe that is the checksum doesn't track modifiers on the header. But before I was doing this video, I said, well, maybe I can just force some sequence numbers in there. And so I was adding modifiers. And so I will say, okay, well, let me add this modifier. And basically where I just incremented the sequence number and acknowledgement number and all that other fun stuff. And come to find out, these modifiers don't really work in this TCP header. And I'm not exactly sure why. Maybe Xena can chime in and tell us. But anyway, after how the state machine is supposed to work anyway, I don't think adding an incrementing value on both sides is gonna actually be a state machine. So that's not gonna work anyway. So anyway, so you can add a TCP header and we can run it. And let's see. Let's preview the stream. And you'll probably see Wireshark is going to complain quite a bit. Yep. Yeah. It doesn't like any of that. And of course I didn't plug any numbers in there. I don't know what's it erroring on. It says TCP analysis, TCP 0 window segment. Okay, so it didn't like my window size, and you could mess or plug different numbers in it, but it's not going to make any difference because it's not supported on this platform. But one of the points I wanted to make with this is if we go to, let's go ahead and I'm just going to leave this TCP header just default. Bunch of zeros. It's invalid. But the layer 3 IPv4 header I have set up correctly. The router is a layer 3 device. It should just ignore this header. So let's try that. Let's go ahead, and I'm going to go ahead and I need to fire up some ARPs. Enabled, suppress, enabled. Okay. So let's go ahead and fire up. I'm just firing up all the ARPs to get the switch MAC address lookup table squared away. We'll start it. Okay, so let's go over here and stream 00 is our TCP stream. And let's go ahead and fire them up. All right. So resource properties, state enabled, traffic status on. Okay, so we got our stream running. Now its destination is port 3. So I'm going to highlight port 3 and go over here to global stats. And I'm going to go over to capture. Maybe. There we go. I'm going to start the capture. And sure enough, we've got packets. So the router is passing them. Now if we look at this in Wireshark, it's not going to like them. But we know it's getting through the network. Okay, so I'm going to go ahead and stop all the traffic. And I'm going to go ahead and fire up that. Oh, I need to release this port and this port. Right click, release ports. All right, because we are going to use them for our 2544 testing. Okay, so I went ahead and fired up the 2544, and this is basically what it looks like. It's just an application that's running to the Xena compact chassis. And let's see, we need to add a chassis. All right, so we're going to use port 0 and port 3 that were released. Okay, and let's see, add Xena chassis. This is so nice, this little quick start, because I always forget how to do it. Selected test ports you need to use, and then drag them to selected ports. Well, that's a little bit old, but let's see, in the selected ports panel you can then configure the individual properties. So I've highlighted them. Let's go to selected. Okay, so it's found them, port 0 and port 3. Ah, okay, so see this protocol segment profile? It's set on Ethernet. Ethernet does not use IP addresses, right? So we need to go over here to the protocol segment. I'm going to go ahead and add a profile. Okay, so I've added the Ethernet frame. I'm going to add an IPv4 header. Okay. And I'm also going to add a TCP header. All right. We're going to go back over here to selected ports. And we're going to say we want to use this TCP protocol. Okay. All right. For both of them. Okay, so now we can add our IP addresses. So, oh boy, I have to remember the IP addresses. It's 192.168.11.16, I think. And the gateway is 11.1, that is correct. And it's terminating to 192.168.11.162. Well, it's not. Anyway, the second one is 162, and his gateway is 161. He's in a different network. And okay, that looks okay. And you notice that I didn't do anything with the TCP header. I I could probably add source and destination ports in here, but as we saw earlier, it doesn't really matter. So, okay, so let's go back to our start page. Test configuration. Okay, so we've done the selected ports, configured the individual port properties, done that. Test configuration panel. The property is divided into topology and frame content, test execution control, test types configuration. All right. So let's go to test configuration. And we're going to do just pairs, east-west. We want the IEEE default, different frame sizes. And that's about it, I guess, right? Oh, okay, so that was a topology and frame. Okay, test execution. Okay, well, I'm going to just leave this text execution control default. And let's see, it's test types configuration. So we're going to do throughput test, latency and jitter, frame loss, and back-to-back. And we can read through these, but I'm not going to. Why not? Let's see if it'll run. So let's go ahead and start it. Okay, so I guess this is where it's going to put the results. I don't know, NEV blog, oops, test. Oh. Okay, so we must assign, I had an error, must assign the port to a port group. You must assign a peer to the peer group. Well, we definitely missed that, didn't we? Selected ports. Oh, there we go. Oh, that's pretty funny. Okay, so it's east-west. Wow, I really don't remember this, do I? Okay, so here's west, here's east. If you look under this topology and frame. So it'd be nice if they had this picture on the selected ports, but so okay, so we'll do the east port as port 0, the west port as I'm sorry, the third port is the west port, and then okay, yeah, so what's happening is saying this port peer is destination. Why they don't call it destination, I don't know. Okay, so we want 0 to its destination to be on 3, and port 3 to be destination on 0. It automatically populated that for us. That was very nice of them. Okay, let's try this again. Let's go ahead and start it. Uh-oh. Well, now our packet size 64 too small for protocol segment, need 80 bytes. I ran into this packet size problem when I was building those ARPs in one of the previous videos, and I don't remember, maybe I just disabled the payload altogether. I don't remember how I actually got around that. So I just added the custom sizes, which is basically the IEEE defaults, with and just started at 80, so we didn't run into this problem. Anyway, another thing I was thinking of while I was poking around is we need to set the DF bit in the IPv4 header. So I went ahead and looked it up on Wikipedia in the 3-bit field. So bit 1 is a don't fragment bit. We need to set it to 1. So let's just set this guy to 1. Alright. Alright. Let's try to run it now. Okay, it's running. So when it's done running, I'll be back. Okay, so I was running this thing, and I was looking at the result data, and I noticed everything was failing. Okay, so I had a couple errors. One, I didn't have the subnet mask set right. They were both set at 24, which is incorrect. So I fixed those, and I also had the default gateway for port 0 as 11.1. It's actually 11.2. And I should have probably, I just getting lazy. I mean, it's set in a test set right here. In the Xena Manager from when we were doing our previous testing. I just was too lazy to go pull it up and look. And of course I could also pulled up the network drawing for that matter. Okay, so let's give this thing a whirl again. Okay, so that was about as much fun as watching paint dry. So we got to take a quick look at this this very nice test report. Xena did a good job on this. We'll do this quickly. So yeah, this gives name, date, time, duration, generated. I'm sure a lot of this stuff is customizable if you have to give it to a manager or something like that. But it captures the config. Excellent. Gives you the test setup and the results. I like this summary. All tests pass, because a lot of people don't want to just read through these numbers. So let's see. This is throughput, and I won't read through all these numbers. You know what we're looking for is there any frame loss and no errors. Looks like it passed everything and it sent. Theoretical latency and jitter. I was kind of looking at this while it was running, and I did notice, and we noticed this when we were doing the lag testing, that the latency on going to the Juniper was higher than the latency coming back from it. And I'm not exactly sure why that is. It's I wouldn't say it's double, but it is kind of odd. Yeah, so it's, yeah, I just don't understand that. And it keeps going up as the frame size goes up. Yeah, that's a curious result. Anyway, so that would be something to, you know, dig into if you are a network engineer and wanted to get more information on it. So this is a frame loss rate test result, and of course we didn't have any frame losses, and that's a pretty boring graph right there. There's nothing on it. Let's see what else we got. Back-to-back test results. Used, everything looks like it passed. That's a 50% rate, 100% rate. Yeah. Yeah, we could probably dig into these a little bit more. If you guys want me to look at this more, just leave a comment in the comments, and we can tinker around with it. We can also look at, setting this, where is it? Setting this size up, and to start where it actually starts dropping packets, so we can actually test what the maximum size is. I don't remember setting up jumbo frames and anything, but so yeah, we could keep increasing these sizes till it starts dropping something. We could also change the speed. So where did I see that? Yeah, this this max speed right here, we could actually increase that, especially going from the gig to the 100 meg. We could overload it a little bit. So what did this tell us? Well, it told us that layers 1 through 3 are pretty good, and adding the TCP header didn't cause any ill effects. And before you say, well, it's a layer 4 thing, well, you have to remember that in the IP header, you tell it it's an actual TCP frame, which on a router could actually do something with that if it was set up, like queuing or quality of service or something like that. So even though we have the DSCP set for best effort, it could also look at this protocol bit, or might even react to the protocol bit for that matter. I think I'm about done with this video. I don't really know where else to go with it. I think this would be good for a network tester. If you're trying to set up hundreds of TCP connections, this isn't your tool. But as we looked at in the RFC 6349, we could get, looks like 2 of the test results from this test set. So that might be all you need. So anyway, I hope this helps. If you have any questions or comments, leave them in the comments below, and I'll see you next time.